Okay, I think I'm recording. So here we go. We are going to work out some problems here on Physics Homework 3.2. So we've done these already in class, but I'm going to work them again in case you need some reinforcement. So we're going to use 10 meters per second for the value of little g. That's the acceleration of gravity near the surface of the Earth. All right. And here we go. So we're going to toss something up in the air, straight up in the air, and it returns to its original position in 2 seconds. So what was the ball's initial velocity? How fast was it thrown? And how high does the ball go? Right. So depending on the kind of variables you feel like using, that's either delta x or delta y. We'll just call this delta y. It's the same as delta x. I'm just using a y instead of an x. And the initial velocity, so that means we're looking for v naught. All right. And so I'm going to sketch a little diagram here. All right, so here we go. We're going to toss this thing up in the air. And it momentarily stops at the very highest position. When you toss something up, it slows down and stops. And then it's going to fall back down. Bloop, okay. And the total time it takes to return to its original position is 2 seconds. So t total is 2 seconds. So as I've said before, for motion like this, where an object is tossed up and then comes back down to the same horizontal position, these problems are symmetric. However long it takes going up, it takes the same time coming back down. So then the time to get up here to the very top here is 1 second. So I'm going to work the problem out as though it's just being tossed up in the air and stopping up here. We can still use that to find its initial velocity. In fact, we probably don't even need to know the information about it, when it lands, except that the total time was 2 seconds. So next, coordinate system. All right, so you should have a coordinate system for all of these problems. So here's my coordinate system. And the next thing you need to do is decide which direction is positive. So typically up is decided to be the positive direction and down is negative. You could flip those around if you want to, no problem, as long as you're consistent and you keep with those conventions throughout the problem. Next, I know the acceleration of gravity here. It's about 10 meters per second down per second squared. And that acceleration is directed downward, which is a confusing concept. We've talked about this in class. The acceleration doesn't always point the same way that an object is moving. In this case, the acceleration of all objects near the surface of the Earth, that direction is downward, even though the object may be moving up or sideways, or fast or slow. It's always about 10 meters per second squared, and it is directed downward. So in this frame of reference, that means the value of a that we need to use is going to be minus 10 meters per second squared. That is also, by the way, that's also called the value of little g. All right. So in this case, little g is minus 10 meters per second squared. Next, goodness gracious, what is its initial velocity? So we have a set of equations here, although, think about it. If it's losing 10 meters per second squared, every second it's in the air, and after 1 second it completely stops, how fast must it have been thrown with to stop in 1 second, knowing that it's slowing down at 10 meters every second? Yeah, it has to have been tossed up in the air with a speed of 10 meters per second. But look, let's look at some of the equations we have here because some of you are more comfortable with these equations. And one of them says V final, the final velocity, is the initial velocity plus acceleration times time. So you can plug the numbers in here straight away if you want to, right, which we can do. Or you can algebraically rearrange these things. Let's just substitute in the values for these values of numbers here. So V final, up here it stops, so that means that this is 0 meters per second. And that's equal to V naught plus, well, the acceleration value we're using is minus 10 meters per second squared. Times, it takes 1 second to go up there and stop. So let's just look at this here without the dimensions on it momentarily. You can't just toss out dimensions, though. Those are really important for consistency and seeing if you're on the right track. So 0 is equal to V naught, and then plus minus 10 is minus 10. So V naught minus 10 times t. Oh, wait, t is 1 second. Hello. All right, so that means that 0 is V naught minus 10. So what do you subtract 10 from and get 0? Blank minus 10 is 0. Yeah, V naught's got to be 10. Or algebraically, the way to solve this is to add 10 to both sides. And that cancels out the 10 over there. And so that gives me that V naught is 10 meters per second. And this is also consistent dimensionally because this 10, yeah, it's 10 meters per second squared. And this 1 is 1 second. And that 1 second here is upstairs. You've got seconds squared downstairs. So one of those guys cancels out and you're left with meters per second. So there you go. The next question is, how high does it go? So that's delta y. Well, it's exactly the same as what we've been using, except what we've been using is delta x is v average times t. It's delta y is v average times t. So what was the average velocity of this thing? Well, it started off moving 10 meters per second. Right? When you first toss it up in the air, its V naught is 10 meters per second. At the very highest position, it stops. So its V final is 0 meters per second. So what is the average of 10 and 0? To find the average of two numbers. And you can do this in this case because the acceleration is uniform. Generally speaking, you can't find the average of velocity by taking the average of two velocities. But if the acceleration is uniform and constant, yeah, that works just fine. So the average of 0 and 10 is 5. So delta y is 5 meters per second times 1 second. And then dimensionally, again, this is consistent. That seconds downstairs cancels with the seconds over here. And you've got delta y is 5 meters. And you put a box around it. So there you go. And so then I'll go ahead and stop and save this and upload it for y'all.